Hello, everybody. My name is Huy, and I guess everyone haven't met me in the person yet, except Dr. Dũng and Long. So here a brief introduction about myself before we start. So my full name is Nguyễn Quang Huy. I was a research assistant at Uni Illinois Smart Health Center, and later a personal research assistant for Dr. Dũng. And my research interests are about feature learning, domain adaptation, and Bayesian optimization. So my in the main knowledge about large language model and recommendation is zero. So if in my presentation, if there are any mistakes, please support me to shed the light to everybody. So today I want to present the paper ReLLa Retrieval-enhanced large language model for lifelong sequence behavior comprehension in recommendation system, which has just released on the archive uh, in the previous month. This is the joint collaboration between the Shanghai University and Huawei Research Group. So basically, in this paper, the author team is claimed that they are among the first team to identify and formulating the sequencing behavior in comprehensive problem for large language model, and they support in the recommendation system, and they propose the ReLLa Retrieval-enhanced large language model to adapting and empowering the large language model for zero shot and few shot recommendations tasks. So basically, in the problem, the sequencing behavior in comprehensive problem is the problem where large language model fail to extract the useful information from textual contents or long user behavior sequences for recommendation tasks, even if the length of the context is within the concept limitations of the large language model. So they are among the first team to identifying and formulate the problem, and they conduct very extensive experiment and application study to validate method in actually improving the large language model. So as I previously informed you about the problems in sequencing behavior in comprehensive. So basically, our aim is shortcut to extract useful information from long user behavior sequences. For example, in this figure one, they compare the performance between the traditional method as DCNV2 in the full sort and the large language model Vicula 30B in zero sort, and with different types of user behavior sequences. So the more the case is enlarged, the traditional method, the CNV2, become more stable and steady improvement in the performance, also in the blue light, but the performance of the large language model is highly unstable and is at the prone to reduce the performance. And in the left side is the sample of the user behavior sequences with the length k, including the for for movies, as well the recommended as well as the interested score for each movie from a person. So basically, when the number of movies of the user behavior and last, as so in the figure, large language model achieve unstable performance when the method when the user behavior sequences is enlarged. So basically, they are the first team to formulate this and improve the problem, which leads to the zero source and few source recommendation system. So basically, zero source recommendation system implies that the model is directly employed for the target recommendation task without any support image from the in-domain training data when in the future recommendation, they allow to train on the small size number of sort, which are from 256 to 8192 sort according to the paper. And this is the sample where they formulate the user behavior sequences by formulating the input and output pair at S and Y, defined as the Y is the binary label level. And basically, as the in this image, the outputs of the every movies from the star from 1 to 5 star for rating. They decided to have the star 4 and 5 star to be to be inferred to be yes, to be the positive value yes, and with 3 star to up to 0 to be indicated at negative label. And S is contain the textual description for the user profile, the user behavior sequences, the target item, and the task description, respectively, as shown in the illustrations. And the user behavior sequences can be changed into the length of case, which in the figures have the length of k by 4 indicators the user have the history of watch only for movies. And for the LLM, they formulate LLM as the points-wise scoring, as basically the data set is built for the click-to-grade prediction indicates that the indicate for the recommendation system to estimate a user click probability toward the target item, and they formulate as at the SYI is the predictions of S to the large language model and bring to the subback layer for the probabilities of recognize of choosing the movies. But however, while we convert the output Y into the binary value, they use the follow formula by using the epsilon between the scoring between the yes and the no value to scale the Y into the binary output. So basically, in the paper, they propose ReLLa for improving the performance of the yellow source and few shot recommendation system to in the large language model problems. And basically, in the left figure is the method for the zero shot, and the right figure is for few shot. So in the zero shot learning, they propose the semantic user behavior retrievals, where they replace the k most recent item by k's more relevant item behavior in the testing sample, where they want to enhance the qualities of the testing sample while preserving the length of it. So that the large language model can base on the testing sample to predict better to predict to extract better information from user behavior sequences. So basically, from the item pool, from the testing item pool, they after the large language model problem, they fit to the average pooling as well as the principal component analysis module for the reduction and denoising, and that's lead to the semantic vector. Based on the semantic vector, they compute the code size similarity between individual vector with each other, and they select the top k relevant vector to enhance the to replace the most recent item in the testing sample, and therefore improving the performance of the testing while reserving its length. On the other hand, in the field of recommendation system, they adopt the semantic user behavior as the augmentation to improve the training sample by from the original data. They apply SLBR to and the enhanced data with top K relevant behavior. And then they compile the original one and the enhanced one together for the mixed training data. And they use the instruction tuning to train the large language model for the future recommendation system task by and the method is called the retrieval-enhanced instruction tuning. And by doing so, they claim that they prevent the large language model from overfitting and improve its properties and generation abilities and thus effectively extract useful information in long user behavioral sequences.
Lee, can I
Yeah,
ask? So can you go back to this diagram? So the
yeah,
semantic user behavior retrieval. So given a target item, it will look into
yeah,
the past interactions of that user, right? And then find
yes,
out which movies are semantically similar to the target item, right? So
yes,
let's say
yeah,
Spider-Man, right? Spider-Man 2, right? So let's say if you have watched Iron Man or Avengers or others Marvel's movies. So given Spider-Man 2, I will look it up, right? And I found that you have watched and give some ratings to Iron Man's and Avengers. And let's say they are all high scores, right? So based on that,
yeah,
I can reason, and the LLM model can reason that look, all of those movies relevant to Spider-Man 2, you give high scores, right? So I can say maybe
yes,
Spider-Man 2, you likely gonna like it and give maybe high ratings. So the answer would be yes, right? So is that
yes.
the pipeline? Is that the idea of this retrieval augmented or retrieval enhanced uh, instruction tuning?
Yeah.
And
Sorry, what did you
but
say?
this
Because uh, yeah, in the later part, I cannot hear you clearly. So can you repeat in the later part of your question about instruction
so
tuning?
but I mean, what is the difference between this ReLLa framework with other retrieval augmented recommendation papers?
Okay. For that, I haven't read deeply about all the recommendations, all the recommendation system paper. Yes, so uh, I guess I cannot answer the question right now.
Maybe they use LLM to generate the, like
Yeah, I
the
think they just simply use the I so uh, in fact I don't know much about instruction tuning, but I guess they just simply in the retrieval enhanced instruction tuning method, they just simply improve the performance of the quality of the training data set. And it's so basically it's just the data augmentation for the feature learning.
Can you show the baselines? What are the baselines of this paper?
Oh yes, yes. Here is the baseline of this paper where they both compare the with the large language model based and the traditional recommendation method based both on zero shot, few shot, and full shot. And they claim that the ReLLa method is outperform the baseline in zero shot and few shot and approaching the performance of DIN in the full shot setting, where DIN is probably a split to grade method for recommendation system.
So in the case of zero shot, what the retrieval module will return? Let's say you have Spider-Man 2. Yeah, what would be the output of the retrieval model?
Yes, I think the output of the retrieval modules um, is the recommend is the some recommendation is the yes or no indicating if I mean like the input is providing a list of movie for us as well as a recommendation image, and the output should be if it should be indicates if the user is like this movie or not. For example, if you as in your previous example, you say you like Spider-Man 2, Avenger, Iron Man. However, if they provide the movie Titanic and say if you like the movie or not, so based on the history, the recommendation system predict that if I truly like the recommended movie.
But I thought in the zero shot situation, you only have, let's say this user is male, right? His job is
Yes.
college student, his age, but it doesn't have the watching histories. Like basically, they don't have the list of 4 movies that this user have seen, right? So this goes directly to the question whether they like Titanic or not, a Titanic movie or not. Is that zero shot that you're talking about? Like you don't have the 4 movies yet. You only have the question of whether you like Titanic movie or not.
Oh,
What is zero shot and few shot in this case?
in this paper, they indicate that the yellow shots is where the target recommendation task is turned in without any support from the in-domain data. So I guess it maybe they use the different type of movies in the training and different type movie in the testing, because they only perform the experiment on the data set on one data set where about movie recommendation about recommending movie.
Yeah, because when there's no data, then it relies entirely on the training data of the language models, right? Whether the language model has seen some documents about these kind of movies. So then they can, based on that knowledge of the language model, to deduce whether a user like a movie or not. Is that correct?
Yeah. Yes.
Okay, so the only difference between zero shot and few shot is that whether you have some data points or not, right?
Yes.
Yeah, so that goes back to the question that I asked, like, how is that different from other retrieval augmented generation papers?
I guess the main difference is they use SUPR to enhance the qualities of the data set, and this support the large language model from uh, obtaining the most useful informations and stabilize the large language model in long term predicting of the user behavior sequences. So I think that is the main points of the papers, because they quite claim that in the paper as the one of the first team to formulate and uh, to tackle the problems of uh, the user behavior via sequencing in comprehensive.
Do you have any slide on what exactly that they are doing with the instruction tuning?
Sorry, can you repeat again because I cannot hear you.
What exactly is happening in the instruction tuning part?
Oh, I think I should open the main papers for.
Yeah, maybe you should open the paper.
Yeah.
I think one of the contribution is that they identify the problem of apply large language model for the comprehension.
Yeah, they told that they leverage the casual language modeling objective for instruction instruction tuning to retain the original model structure, but honestly, I really do not understand this talk much.
Like for example, the paper that Lam presented, right? It's zero shot, right? It doesn't relies on any. Well, it's basically say I have watched this movie, and then next movie A, and then movie B, and movie C, right?
Yeah.
Can you recommend me the next movie?
Yeah.
But no, it's still this one. Theory asks whether this user like this movie or not, right? So. So you have a target, yes, because you have a target, so you kind of you can. But it's how to say it depends on you can actually use this for the third question that in the paper that Long presented. Like I have watched all of these movies, right? And then can you recommend me what other movies? So you can actually do the same thing here. Instead of replacing the target item, you use LLM to encode the entire histories of the users, right? And then you have the SI just like in your slide, and then you retrieve among all the items which item has most similar to SI, right? So you also can retrieve the relevant items. Yeah. So that's why I'm wondering, is it really the first paper that formulate this problem in that way?
Yes, and they are quite claiming that over and over throughout the paper about the long behavior problems in the LLM.
The inclusion tuning is mean that in our dataset, we have to make it into inversion dataset with the prompt in the answer.
Okay.
Yeah, it means that we have to modify the dataset before we put it into the online.
Okay, and the instruction is the one that we show on the.
Yeah, that's what's in the prompt in the
Okay.
answer.
Okay.
It's prompt answer, prompt answer, prompt answer. Yeah. The original dataset just the label.
So basically, in this paper, they try to extract some information like from who is he, what his job, and how many age he is, something like that, and try to put it into a model which will retrieve what they think will be relevant to the target item before they decide to put it in another training model to decide whether that target item he or she like it or not, right?
Yes.
And anything else? They have 4 research questions here, right?
Yes. So, but yes, they have 4 research question here, and in the first one, they is table 1 where they compare the method ReLLa with the baseline model in the future in both few shot, zero shot, and full shot learning to validate if their performance are outperforming the other baseline method. So basically, as you can see here, the ReLLa is quite outperform the other baseline both in LLM and traditional methods, and reaching the performance and nearly reaching the performance of the full shot learning. So, and in the research question two, they compare the ReLLa with the baseline model with respect to the life to the length of the behavior sequence to see to validate how stable ReLLa is when dealing with long sequences of recommendation of the movies. And as in the figure 6, they show that the ReLLa is quite stable and, and mitigate the incomprehension problems of the RLM in the long user behavior sequences recommendation. And for the research question 3, they perform the ReLLa in the number of shots to see if the performance of the ReLLa can be different with the respect of the number of shots. And similar to the feature learning problem, the more number of shots, the better the performance of the model usually is. So given the more shots to change, so that the performance of the proposed method is increased. And in the last questions, they perform the ReLLas with the different component to see which version of the ReLLa achieves the best method. And they come out that the complete versions which I present in the previous slides are the best, where they have the two components for enhancing the performance of the testing sample and enhancing the performance of the training sample to tackle both the zero shot and three shot learning. Yeah, where they employ the SOVR and EIT to support the large language model in few shot and zero shot recommendation system. And finally, basically, this papers is where they claim that they have identified and formulate the incomprehension problems of the large language model on lifelong sequence behavior, and they adapt to component semantic user behavior retrieval and retrieval-enhanced instruction tuning to support the large language model in few-shot and zero-shot recommendation system. And in the experiment and application study, they showcase that the method outperform the both traditional and large language model baseline in both few shot and zero shot learning. Yes, this is I'm reaching the end of the my presentation.
Thank you. So let's say if Dan wants to work on this, right? What is your recommendation about what is the next problem that Dan can do? Can you hear me?
Yes, can you repeat the question?
So let's say if Dan or Lam or any of us want to extend this work, how do you recommend us to do that? Do they discuss anything about the future work?
Oh, I think they do not. I think they do not mention anything about the future work. They are mainly focused to improving the performance of the language model in recommend in ranking and recommendation problem, but actually they have only focused on the click-through rate prediction. So I guess that we should further explore uh, mm, the problem that they propose about the behavior long sequences in comprehension, and to see if they have if there are any gap we can explore in the future. Because I think that they, although they claim that they are the first team to tackle the problems about sequence behavior in comprehension, but but from the papers I find that they do not have do not dig in detail about the challenge. So I think there should be any thing if we dig a bit deeper about the problem and to see if we can conduct for apply for improve for the large language model for such challenge.
One question I have actually is like why do they formulate the instruction in this way? So because you need to have a target item, right? So that means
Yes.
if I have the history of users, then I have to ask this question for every other movies. Like for example, I have 1,000 movies, right? Do I need to ask that question for 1,000 times?
What do you mean for 1,000 times?
So the question is whether the user gonna like a particular movie or not, right?
Yes.
And let's say you have 1,000 movies in your systems.
Yes.
So you have to ask that question 1,000 times.
I guess they just asked only the same, only the one question given 1,000 movies at the history.
Because for each user, they have to ask 1,000 times whether that user likes that movie or not. And that's going to repeat for all the user
Uh, uh, uh,
and for all the item as well.
well,
So we are just wondering whether, like, why do they create the instructions in that form? So
yes.
they can instruct like, okay, this user have watched these 4 movies, and then I can recommend the 10 movies that he can watch, right?
Yes.
Instead of saying whether this user like Titanic or not.
Yes. I basically I think that when they make this question, they just want to formulate the input and the output in this testing input and output pair for validating method. But in real life, they can because basically that in this problem they predict on the click to rate, which is the probability that if the person is clicking to rating or clicking to one particular movie or not. So I think that it just this from is just the method of they formulating the problem for validating the method, but in the practical application, they might change to another convenient recommendation and output rather than providing say 1,000 question for 1,000 movie.
I mean, the only use case that I think it makes sense is when you have a movie or an item that you want to promote, right? And then you
Yes.
want to see whether among all the users, which user gonna watch this movie or buy this product. So you can ask these questions. It's like, okay, it's like
Yes.
targeted promotions. So I asked this question, and all the users that are the LLM model say yes, then I will maybe show this movie or product to them. Right? This is more like a targeted promotion or setting. This is
Yes.
not the other way around where you have the history of the user, and then you ask what could be others products or movies that this user might like.
Oh, I see.
But I'm not sure whether they use that use case to motivate this formulation or not.
Yeah.
Right? Because like in
Yes.
the advertisement, so you have an ads, but you need to know who are the users that maybe gonna like to watch this advertisements. You should not send to everyone, right? Because it's gonna be very spam. They so usually this could be targeted kind of recommendations.
Yeah. So
Okay, any questions from others?
Yeah, I think one problem we need to consider when we apply a large language model for recommended system task, that's the inference time. As I think the computation cost for inference natural language is more expensive than the metric computation in the traditional recommendation. And furthermore, in this paper, I think one of the main contribution of this paper is that the way they try to retrieve the information from item pool. For example, in the figure 3, they utilize large language model to extract the feature vectors from item pool, and after that they use PCA to transform it to another low-dimensional space and compute the similarity between vectors. And after that, they can enhance and augment the data for tuning the large language model. However, the most thing I think we need to clarify and clear in this paper is the research question 4. That's what are the influences of different components in their framework? Yes, and the research question is answered by the table 2 in this paper, and they try to decompose many components in that paper. And however, I'm not read this paper carefully, so I quite have some concern between mixture and retrieval and resource and instruction tuning. Yes, I quite have some concern and something unclear in
yeah.
these two components.
Yeah.
Yeah,
So
should we?
basically, okay. So basically, the retrieval is when they combine the original image and the enhanced original data and the enhanced data from the training one for the mixed data set, and they tell that this is the mature data set for instruction tuning the LLM, and the retrieval is when they only use the top relevant behavioral data only, the enhanced version only without the original one. So that is
So how
the version.
about mixture?
Sorry, sorry, Long.
So
What did
how
you say?
about with our mixture? So how about
Yeah,
with our mixture?
Yeah, without mixture is they usually only use the original data only, and without the retrieval. What? Right, without the retrievals is they tell that they remove the semantic user behavior for both training and the testing, which are the testing, the training and the testing are both the original sample, and without the mixture is they only use the enhanced version that they produced by the VR, and they do not use the original data.
Mm-hmm.
That I have just scanned the original paper and I still not find where is the instruction for the instruction turning. So basically, just understand that this is a new framework to combine both the CTR model as well as the large language model as a new one to adopt with both zero shot and the few shot scenario. So I think if we can answer the question that what is the instruction turning is, we might understand why it just like a just no question in here, because overall the just no question list will be put in a mixed data set and combined with another large language model to return something in the instruction turning. So I don't really think that this framework gonna generate like just no question for each data set. For each data point, it might return the whole table, or whether this user like this item or not.
I see. Yeah, I think
Yes,
that they proposed the method at the framework for support the LLM in Resort and Yarosort recommendation system rather than they use just the method rather than the model.
Yes, because I seen in the introduction when they said that the problem will target into click to rate. So with that
Yeah.
problem, I don't think the output must be something like just no. It must like return the whole data set to this side. It's just my personal
Yeah,
talk because
so
I haven't seen anything talking about the instruction turning. The table is just like a framework with part will return what into which step, but no clear description about instruction turning.
yeah, I see.
Another thing we can consider about this paper, if we can go to the session 4.5.
4.5.
Yes,
Okay.
on the
Yeah.
framework hours, they denoted by hours. They said that the training dataset consists of both original data and retrieval-enhanced data, and therefore their training data is containing 2 N samples. However, the testing datasets only contains the poor retrieval-enhanced samples. So I think in this case, they only show the result on retrieval-enhanced dataset.
I think they keep it for other setting as well. Also for Retrieval-enhanced.
On and then when they consider the framework denoted by without mixture, they also use the testing datasets, a retrieval-enhanced dataset. However, when they consider their when they consider their framework without retrieval, their training, their testing datasets is the original dataset. Yeah, so I think the setting in this paper is not really good. When they compute the performance AUC or localhost or ACC with different testing dataset, right?
The results from without something, but not very clear. That
Yeah, they didn't mention clear about how they instruction tuning. That's the problem.
they just say that without instruction, this will become the real short version. It means that it connects purely on the large language model without anything. It's still very hard to re-implement it without the function effort.
I think they assume that instruction tuning is a well-known term in large language model.
Can I have a question that I'm not expert on feature learning? So what is the difference of the framework built by without instruction tuning and 1/2 and sort? What's the difference between instruction tuning and feature learning?
Yeah. Well, actually, I think they do not have any they do not say relevant setting between without retrieval and have and sort learning, because basically feature learning is we train the model with very slow very small amounts of sample data, right? And have and sort learning is where we reduce the small number by half. So I think that the system where ReLLa would have and sort learning is better showcased in figure 7, where they showcase the performance of the method across the number of sort. So it is quite clear in figure 7 rather than at table 2. Because they are just the have and sort is just a smaller number of sort for feature learning rather than different in components like other options in the table 2.
Okay, thank you very much for presenting this paper, and see you next week.
Yeah.
Thank you all of you for joining the
Goodbye, Huy.
presentation tonight.